The purpose of these exercises is to introduce you to the charting functions in Excel. The first example in the textbook introduces us to a scenario where we have the percentage of the population living in poverty and the violent crime rate per 100,000 people in 2009 in the 6 New England states. So we're going to look at both a bar chart and a pie chart in order to decide which display is better for our data. The first thing you'll need to do is enter the data into Excel so that you can use the values from the textbook to create the charts that we're going to show you today. As you can see here, I have already entered the data from the textbook. You will need to enter in a column for the states, the poverty rate, and the crime rate. Once you have all of the data entered into Excel, you can begin to insert the different types of charts. To insert a chart, you must first select the data you want included in that chart. We're going to select the state and poverty columns because we're first going to look at a chart of poverty by state. To insert a chart, you click on the Insert ribbon at the top of the screen and go to the section where the charts are outlined. As the textbook states, we could click Recommended Chart and let Excel decide which chart is best for our data, or we can explore different options on our own. The first chart we are going to explore is a pie chart. So we navigate to the pie chart button and click on it. We then have a couple of options to choose from, and as we move our cursor over each option, we can see that an example is displayed for us below. We're going to choose the 3D pie chart. Once we select it, it will appear in our workbook. As we hover our cursor over different slices of the pie chart, we see a little box pop up that tells us the rate and which state we're hovering over. There's also a key at the bottom of the chart that shows us which state goes with which color in the pie chart. This is clearly not the best way to display these data, so now we're going to explore a better option, and that's a column bar chart. So I'm going to select this chart and delete it. I'm going to leave these sections of the data highlighted because we still want to make a chart that covers poverty for each state, but this time we're going to go up to Insert and select the column bar chart. Just like with the pie chart, we have a couple different options to choose from, but in following the textbook example, we're going to choose the 3D column chart. So we see our chart produced below in the workbook. You can easily reposition and resize the chart by using the mouse. You can also choose to get rid of certain elements like the title just by highlighting them and clicking delete. You can see that actually makes the chart area a little bit bigger and easier to read. We can also choose different styles or formats for our chart to make it more readable or more appealing. To do that, we simply click on the chart area to highlight it. And when we do that, a new set of menus opens in Excel. See Chart Tools here in green appears when we have the chart below highlighted. When we click outside of the chart back into the workbook, we no longer can see those chart menus. In order to access the chart menus, we need to have the chart highlighted. So we'll click on the chart and go up to Design, and we can choose from a number of different formats for our chart. As we scroll along the different styles, we can see our chart below and what it will look like in those different styles. And following the textbook, we'll select style number 3. Once we click it, the change becomes permanent, and we now have a nicely formatted bar chart for our data. If we would like to now create a chart for crime, we can do that by selecting the appropriate data. So we can move this chart over that we just created, and now we must select the state column and the crime column. There are a couple of ways to do this. It's not as easy as selecting the state and poverty column because those are actually right next to each other. State and crime are not, so we can either highlight the state column and then while holding the Control key on the keyboard, select the crime column, or we can simply copy and paste our information below, which will allow us to create a new table where the columns we need are right next to each other. So we can now select our columns of interest and create another chart. I'm going to follow the same procedures as we did for poverty. And now that we've formatted it the same way, we can move them around and resize them so that they both fit on the same page. Now we have created column bar charts for both poverty and crime. Now we are going to explore Excel's histogram tools using the fluoride added to the water example from the textbook. Remember, you will need to have the Analysis Tool Pack enabled in Excel to be able to do this exercise. The steps for adding this tool pack were outlined in Chapter 1. You can see whether you have the tool pack enabled by going to the Data ribbon and ensuring that Data Analysis shows up at the very end like it does here. The example in the book states that many communities add fluoride to water to prevent tooth decay. In a 25-day period, these levels of fluoride were measured, and you see those values entered in here into Excel. So in order to complete this exercise on your own, you will need to enter the values from the textbook for this example into Excel in a single column like we've done here. We will now use the Analysis Tool Pack to create a histogram for these data. We will need to go to the Data Analysis button, which again is under the Data ribbon. When we click on it, it pops up a dialog box with many different options to choose from. We will be choosing histogram for this exercise. When we click OK, we see a new dialog box pop up with all the options for histogram. We need to tell Excel the input range for our data. To do that, we must have our cursor in the box for input range. We can then either enter it in manually or use our cursor to select the data. To use your cursor to select the data, make sure that it is enabled in the box. You can then go into the data field, click on the first cell, and drag down till you encapsulate all of the values you want represented. You can see that it then auto-fills in our input range. Excel allows you to choose the bin range that you would like to use, or you have the option to leave it blank and let Excel choose what it feels is the most appropriate decision for bin range. We do not have our column headed by a label, so we do not need to check the labels box. We also want to make sure that our histogram comes up on a new worksheet, and if we want, we can title that worksheet so it's easy to find. I'm simply going to title this histogram. We also want to make sure we click the box Chart Output, because that is how we'll actually get our histogram chart. If we do not check this box, we will only get a frequency table and no chart. Once we've selected all the options we need in this dialog box, we can click OK. Once we do that, we are automatically navigated to our new sheet, which you can see down here we've labeled histogram. We can easily go back to our data sheet by clicking Sheet 2, which is where those data are entered. But in that histogram sheet that was created, we see a frequency table with all of our data organized by frequency, as well as the histogram that we've asked Excel to create. We are now able to customize our chart by resizing it, removing different aspects of it to make it bigger, and so forth. As we explained, we allowed Excel to auto-create the bin width for our histogram. Typically, histograms have bins that are connected in order to represent the fact that the data are on an interval scale rather than categorical, with the bin centered over the midpoint of the range. Excel does histograms differently by creating separated bins labeled by the upper limit of the range. Keep this distinction in mind when interpreting histograms made in Excel. Now we will show you how to create another histogram for the fluoride data that has 4 bins created manually. The first thing we need to do is determine the boundaries of the bins so that we can determine the parameters necessary to create exactly 4 bins. We can do this by utilizing Excel's min and max functions. We're going to go back to the sheet where our data are entered and locate the minimum and maximum values. With a data set this small, containing only 25 values, we could easily eyeball these data and figure out the minimum and maximum value. But with data sets that are much larger than this, that is not always possible. So we can use functions in Excel to pinpoint the minimum and maximum values without having to actually look through all of the data and find them ourselves. To find the minimum, we enter the following formula. We must select the range that we'd like Excel to check for the minimum. So we can see here that the minimum value is 72. And again, we could have easily looked through these 25 values and found that the minimum value was 72, but if our data set were much larger, we would not want to do that. We can find the maximum value with a similar formula. And find easily that the maximum value is 105. We can now use the minimum and maximum values to define our bins. The first thing we need to do is find the bin width for having 4 bins. To do that, we simply take the maximum minus the minimum and divide by 4, which is the number of bins we would like. We arrive at a bin width of 8.25. We must now enter into an Excel a column for our boundaries. We will use this bin width and the minimum value to define our boundaries. Our first boundary will equal the minimum plus our bin width, which is 8.25. Our second boundary will be our minimum plus 2 times our width. Our next boundary will again be our minimum, but this time plus 2 times our bin width. And our third boundary will equal our minimum plus 3 times our bin width. Now we can go back to our Data Analysis button and create a histogram using our manually defined boundaries. This time, we'll want to enter in a bin range. For the bin range, we need to include the boundaries that we've created. To do that, we simply activate the bin range box by making sure our cursor shows up. Then we can go into the data field and select our 3 boundaries. We now want to make a new title for our worksheet so that it does not overwrite the old one. We'll simply call this Histogram 2. Again, we want to ensure that the chart output box is selected so that we get our histogram. When we click OK, a new sheet will open up that shows our frequency table with our manually defined bins. We are then free to edit it as we have done with previous charts. Manually creating different bins is a challenging task that requires a lot of practice. It's also something that is frequently done, so it's helpful to get further practice by going through another example. To do the next example, go to the BetterBusinessDecisions.org website and download the MLB Players Salaries dataset. This is an Excel file that you will need to do the next exercise. Here I have open the MLB Player Salaries Excel file, which we will use to do the next exercise. You can see that we have salary information for baseball players who played in the year 1988 all the way up to the year 2011. So if we scroll all the way down, we can see that we have quite a lot of data. We have 19,544 rows of data, but we actually only have 19,543 data points. This is because our first row is filled with labels for our columns. So although we have 19,544 rows, we only have 19,543 data points. We are going to use these data to walk through another example of manually creating bins for a histogram. Just like before, the first thing we'll need to do is identify the minimum and maximum values. Remember before, when we had a data set of 25 values, it was easy enough to eyeball the data and pinpoint the minimum and maximum values. With 19,544 data points, this task is not as easy. So our minimum and maximum functions in Excel that we've already learned are going to come in handy. Our first step here will be to find the minimum and the maximum values using the min and max formulas in Excel. So I would like for Excel to sift through column C, which contains all of our salary amounts. Now we don't need column C row 1 because that includes the label. The first data point we need is in column C, row 2. And I want to search all the way through, which is the colon sign, to the end, which we know is column C, row 19,544. Once I have that entered into the formula bar, I can click enter and see that our minimum salary value from all those data points is 62,500. Now we must find the maximum value, using the same procedure, but with the max formula. And we can see that our maximum salary is 33 million. Now that we have our minimum and maximum value, we need to find our bin width so that we can identify our boundaries. Let's remind ourselves that we want to find 10 bins. And remember, to get our bin width, we simply calculate our maximum value, which is located in column H, row 2, minus our minimum value in column H, row 1, and divide by the number of bins. Now that we have our bin width, we can assign our boundaries. Our first boundary is going to be equal to our minimum value plus our bin width, which is located in H4. Our second boundary is going to be equal to our minimum plus 2 times our bin width. Our next boundary is equal to our minimum plus 3 times our bin width. So we must enter this formula in 9 times to arrive at 9 different boundaries, which will give us our 10 bin widths. Now that we have our 9 boundaries entered into Excel, we can create our histogram. Remember that to do this, you go to the Data ribbon and select Data Analysis. You can see that Excel will save our information from past charts that we've created. So we do want to reset and enter the values for this Excel sheet. The input range is going to be the salary values. So we want column C, starting at row 2, all the way down through column C, 19,544. Our bin range is going to be the boundaries that we've created, and we can use the cursor to select those because there aren't very many. The format Excel uses to autofill in our bin ranges looks a little bit different than we do it ourselves, but we're still going to get the exact information that we need. We're going to call this tab Histogram 3, and we're going to ensure that Chart Output is checked, and then click OK. We now have a tab that opens up with our histogram for the salary information. We now have a histogram for the salary data that uses the bin widths we've created. The examples we have just gone through all utilized continuous numerical data. We are now going to walk through an example that demonstrates how to use the charting tools for categorical variables. The next example will utilize the Student Survey Excel file from the BetterBusinessDecisions.org website. Here we have open the Student Survey Excel file, which we are going to use for the next part of the exercise. We are going to utilize the race variable to demonstrate how to create a table to display categorical information. Now, with a small amount of data like this, we could easily go through our race variable and identify the categories and the frequency for each group. And we could create a table manually by having a column that defines the category. We see that we have people who identified as white, black, Hispanic, Pacific Islander, or other. We can also go through and easily count the frequency for each category. We can go through and see that 15 people identified as white, 3 is black, 2 is Hispanic, 1 is Pacific Islander, and 2 is other. And that's a quick and easy way to create a frequency table to display categorical information. But if our data set was much larger than this, we would not want to go through and identify all of the categories ourselves, nor would we want to sum up the number of participants in each category by ourselves. So luckily there are features in Excel that will do this for us. This feature is called a pivot table. We can find the pivot table by navigating to the Insert ribbon. We can see that it's the first option listed here. When we click on it, a dialog box opens that asks us to select a table or the range of the data we would like to be selected. I'm going to select all of the data so that we have all of it available in the next phase of creating the pivot table. One thing we want to be careful to do is select New Worksheet so that our table opens in a new sheet away from this original data file. When we click OK, Excel will automatically navigate us there, where we see a potential empty frequency table and all of our variables for our data set. We can now build a custom pivot table. We want to build one for race, so we'll take our race variable and drag it over to the Drop Row Fields Here box. You can see that Excel automatically finds all of the categories in our data and lists them out here for us. We now want to identify the value fields. We again take the race variable and drag it over into this box. Now Excel has automatically created a table much like we did earlier by hand, but automatically. So again, this would be much more useful if we had a large data set where we did not want to take the time to sift through all of the different categories and number of participants who identified as each category. We can now use the tools in Excel to make changes to our pivot table. Say, for example, we wanted to eliminate categories that didn't have any responses or were indicators of missing data. We can see that we have a row listed as blank, which just means that that row or that field was left blank in the original data. If we navigate back to the original data by going to the bottom of the Excel sheet, we can see that there was one respondent who did not indicate their race. So Excel took this blank cell as a category and included it in our table. We can easily eliminate that row by clicking the down arrow, which is located next to our category label of race, and unselecting the box for blank. Right now, the box Select All is checked, so all categories are being represented. But if we uncheck the box for blank and click OK, we can see that Excel will remove that row for us. We can also make changes to the way the data are displayed. Right now, what's being displayed is a total frequency count in the column labeled Total. But if we wanted, we could change this to be a percentage. To do that, we double-click on Count of Race, navigate to the Show Values As tab, and right now, no calculation is being displayed. It's just simply the frequency count. But we can easily change that to be a percentage of the grand total. So when we click OK, you can see that the frequency count is changed into a percentage. And we can easily change that back by going back to that dialog box and returning it to no calculation. Now that we have a frequency table of our data, we can use it to generate a column bar chart. We simply select the data we'd like to use and follow our steps from earlier. We go to the Insert ribbon, click the Column Bar Chart button, and we'll do a 3D column chart like we've done previously. Just like before, we are able to now resize and eliminate any items we wish to exclude. Now we have a column bar chart of our race data. And that is how you can use the tools in Excel to create frequency tables and bar charts for categorical variables.